بسم الله الرحمن الرحيم. أعزائي طلبة وطالبات شهادة الثانوية العامة قسم رياضات لغات، أهلا بكم. اليوم سنتناول درس جديد في مادة الديناميكا، والدرس بعنوان الشغل المبذول لقوى متغيرة. طبعا احنا عارفين ان الشغل هو يحتاج قوة ومسافة، يعني إذا كان في جسم حركناه من مكان إلى مكان فإحنا عملنا شغل. الشغل ده عشان نحسبه لابد ان نعرف القوة والمسافة اللي اتحركت من المسافة الأولى أو من النقطة الأولى للنقطة الأخرى. Welcome my dear student in our math program for second 3. Today we are taking new lesson in dynamic subject. It's titled The Work Done by Variable Force. My dear student, what about the work done with variable force? We have constant force and we have variable force. My dear student, look at introduction about the work done with the variable force. Look at, my dear student, we have the opposite graph. S displacement, F is the force. S is displacement represent on x-axis, F vertical represent in y-axis. The work done by variable force parallel to direction of the motion, its magnitude F, to move the body from SA to SB. In this example or in this figure, we can find the work done by using integration. The work done from A to B, my dear student, is area under curve from A to B by using integration or definite integration from A to B, F ds. My dear student, this rule, very important rule. When we find or the required the work done of a body moved from A to B and with variable force, in this case we find the area under curve between A and B, interval A and B. By using integration, then the work done, definite integration from A to B, F ds, or area of the shaded region A1. Remark, my dear student, in opposite figure we know that the F a part of the shaded area drawing x-axis and the other part through the x-axis. We have two areas, upward and downward, x-axis or displacement. Then we deduce that the work done equals definite integer or definite integer from A to B, F ds, equals area above x-axis A1 minus area of down x-axis A2. My dear student, in the opposite figure, if the force F is constant, this is constant parallel SS. The work done by using the same rule, integration from A to B, F ds. F is constant. Integration F ds by using F constant equals F integration from A to B ds, because F is constant but S is variable. This displacement, my dear student, or ds equals B minus A, equal F times B minus A, or distance between A and B. equal area of shaded rectangle. Area of shaded rectangle, it is easy to find area of rectangle, length times width. My dear student, unless the direction of the force is parallel to the direction of motion, we find the component of the force in direction of displacement F cosine theta, this Fs. Then graphical relation between S and Fs as in the opposite figure. Then the work done by using the rule integration of from A to B Fs ds. Example: a body moves in a straight line under action of parallel force to this straight line, F equals 2s plus 1, where s is distance between the body and constant point O on a straight line. Find the work done by this force from s equals 3 meter to s equals 5 meter. Solution. My dear student, the work done from s equals 3 to s equals 5 equals, we use the rule of integration or definite integration from A to B f ds. What is the interval from A to B? 3 to 5. This s. 2s plus 1, this f ds. By using integration, we know 2s. What is the integration of 2s? Excellent student, 2s square over 2 or equal s square. What is the integration of 1 respect to ds? Equal s. Therefore, w or the work done equals s square plus s side bracket from 3 to 5. By using 5 s square 5 power 2 plus 5 minus 3 power 2 plus 3, answer is 18 joule. Another example. A body moves in a straight line under the action of parallel force to this straight line. Its magnitude F equals 3s squared plus 2s plus c, where s is the distance between the body and constant point O on the straight line. If the work done by this force to move the body from the point O to point in which s equals 2 equals 22 work units. Find the needed work to move the body from s equals 2 to s equals x. Solution. My dear student, the work done in this case, W1 from 0 to s equals 2, definite integration from 0 to 3s squared plus 2s plus c ds. We know that 3s squared is this integration, 3s power 3 over 3. Integration of 2s to s power 2 over 2. And c s plus constant. The work done is 22 from given by using integration s power 3 plus s power 2 plus cs from 0 to. By using substitution about s equals 2, therefore 22 equals 8 plus 4 plus 2c. Therefore constant equals 5. By using the relation, the needed work from s equals 2 to s equals 6 equals integration from 2 to 6. 3s squared plus 2s plus c. Therefore, my dear student, the work W2 after find integration 3s square equals 3s power 3 over 3. 2s equal 2s square over 2. C constant is integration cs. Therefore, by using substitution, answer is 260 work unit. Another example. My dear student, the opposite figure illustrates the action of variable force F. We know that in opposite figure, the graph represents relation between F and S. When S equals 0, F equals 0. When S equals 1, F equals 4. When S equals 5.5, F equals 6. When S equals 8, F equals 0. When S equals 12, F equals 0. Then the force is 0 when S equals 0, 8, 12. The maximum of the force F when S equals 1.5 and 5.5. The minimum value of the force F when S equals 10. My dear student, this relation between F and S, F measured in Newton, body moves displacement of magnitude S measured in meter. Find the work done by this force when body moves from S to 0 to S equals 8. Look at my dear student. When S equals 0, when S equals 8, look at the region above S. What is the figure? Excellent student. This is trapezoid or trapezium. Trapezoid or trapezium has two bases and has height. What is the area? Excellent student. Base 1 plus base 2 over 2 times height, or half sum of two bases times height. Therefore, from S equals 8 to S equals 12 under axis of displacement S is rectangle, is triangle. Triangle which its base from 8 to 12 and its height from 0 to 6. Therefore, from S equals 0 to S equals 12 equals sum from two areas, and from S equals 5 to S equals 10. Look at S equals 5, S equals 10. This is sum of two areas. Solution. Look at, my dear students, the first required from S equals 0 to S equals 8. W1 equals integration from 0 to 8 f ds. My dear student, area of trapezium OABC equals what? Half base 1 plus base 2 times height. Base 1 from 0 to 8, 8. Base 2 from A to B, 4. Height from 0 to A equals 6. Area equal 36 joule. Work 2 from S equals 8 to S equals 12 equals integration from 8 to 12 f ds equals negative area of triangle CDE. Why negative? Because under axis of displacement. What is the area? Equals half base times height. What is the base? From 8 to 12, 4. What is the height? Equals 6. Equals negative 12 joule. W3 or work 3 from S to 0 to S equals 12. Integration from 0 to 12 f ds equals area of trapezium or area of trapezoid or ABC minus area of CDE. Why? Because we have shaded region above S axis and area or shaded region of triangle CDE down S axis. In this case, integration from 0 to 12 equal sum of two areas, but we have area above, area down. We subtract area of above S axis and minus area of triangle down S axis. Therefore, area of a trapezoid or area of trapezium OABC equals 36. Area of triangle 12. Subtract 36 minus 12. Subtract 36 minus 12 equals 24 joule. This is the work done from S equals 0 to S equals 12. Look at, my dear student, the work done from S equals 5 to S equals 10. We have two shaded regions. Look at the green region above S axis is trapezium. Trapezium, its base 1, its length 1, but base 2, from 5 to 8, 3, height equals 6. But shaded region down S axis is half triangle CDE or area of triangle CDK. CDK, its base 2, its height 6. We find integration from 5 to 10 by using area of trapezium above S axis minus area of triangle down S axis. From 5 to 10, FDS, area of trapezium, BXYC minus area of CDK equals have 1 plus 3 times 6 area of trapezium, have base 1 plus base 2 times height minus have area of triangle 2 times 6. Answer is 6 joule. Then we know that by using integration, we find the value of the work done from 0 to 12, from 5 to 10, from 8 to 12, and so on. Kinetic energy. My dear student, we translate to important title is kinetic energy. Definition. Kinetic energy of particle denoted by T is defined as product of half times the square of magnitude of its velocity. Kinetic energy T have mass mv square. M is mass of particle, v is magnitude of the velocity v. From the definition, we know that number 1, v equals norm v, vector v square, norm v square, v dot v. Kinetic energy, particle is scalar quantity, not negative. T must more than or equal z. It's equal 0 when the velocity vector vanishes. V equals 0 or v vector equals 0 or v magnitude equals 0. The particle which moves with uniform velocity, its kinetic energy is constant. The particle which moves with uniform velocity, its kinetic energy also constant. While if the velocity is variable, then kinetic energy also is variable, and it will be kinetic energy at a certain instant equals half m times the square of the magnitude of the velocity at this instant. Proving that the measured unit of kinetic energy is the same unit of measure of the work. Since T equals half mv square, the unit of measure of kinetic energy equal measure unit of the mass times the squared unit of the velocity. Measure unit of kinetic energy T equal measure of unit of the work follow of kinetic energy. Note that the change of kinetic energy of particle between two time instants t minus t naught equals half mv square minus v naught square or u square. Number 2, change of kinetic energy due to collision between two bodies equals kinetic energy after collision minus kinetic energy before collision. The lost kinetic energy due to collision between two bodies equal kinetic energy before collision minus kinetic energy after collision. The lost collision. Watt dot second equal Newton dot meter multiply equals joule. Kilowatt dot hours equals 1000 times 60 times 60 watt dot second equals 36 times 10 power 5 joule. Example. Calculate in kilogram watt meter the kinetic energy of a body of mass 9.8 ton moving with velocity of magnitude 18 km per hour. Solution. Since, my dear student, mass equals 9.8 times 1000 equals 9800 kilogram. Velocity 18 times 5 over 18 equal 5 meter per second. 18 y multiply 5 over 18 to convert it meter per second, we multiply by 5 over 18. Then we know that kinetic energy half mv square. T equals half times m 9800 times 5 power 2 equals 122,500 Newton meter equals 122,500 Newton meter. We can, by using divided 9.8 to convert to kilogram weight meter divided by 9.8, answer is 12,500 kilogram meter. Another example. Body of mass 360 ton moves with velocity 72 km per hour. We have body mass is 360 ton moves with velocity 72 km per hour. Calculate its kinetic energy measured in number 1 Newton meter, number 2 kilowatt hours. Solution. My dear student, mass equals 360 times 10 power 3. Why? Because is ton, when convert from ton to kilo, we multiply 10 power 3 equals 36 times 10 power 4 kilogram. Velocity convert 72 to multiply by using multiply 5 over 18 equals 20 meter per second. Therefore, my dear student, kinetic energy half mv square. In this case, half m equals 36 times 10 power 4, v equals 20, power 2, kinetic energy equals 7.2 times 10 power 7 Newton meter. This is kinetic energy. By using divided to convert to kilowatt hours divided by 36 times 10 power 5, answer is 20 kilowatt dot hours. Another example. Body of mass 400 gram moves with the velocity v vector equals 80 I vector plus 60 g vector, where the magnitude of v is in centimeter per second. I and j are two fundamental unit vectors. Find the kinetic energy of this body in joule. Solution. My dear student, v equal norm v, square root 8 square plus 60 square equals 100 centimeter per second. This is velocity. Mass equal 400 gram. By using divided by 1000 equals 0.4 kilogram. Kinetic energy T equals half mv square. By substitution about m and about v, then kinetic energy T equals 0.2 joule. My dear student, by the end of the lesson, we know that kinetic energy, very important lesson. Kinetic energy, its symbol T, equal half mv square. M is mass, V is velocity. We find mass by using kilogram or gram and multiply by velocity. Velocity with meter per second or centimeter per second. Remember, kinetic energy, very important lesson. My dear student, I am very happy to spend time with you. Thank you. Goodbye.